All right, 2.2. I'm going to talk about finding some things. Find the axis of symmetry. Okay? What else are we going to do? Find the vertex. Okay, what else are we going to do? Tell me if it opens up or opens down. Is it smiling? Is it frowning? Guys in the back, you need to find a seat. You need to have your book open. You need to be taking notes. Let's go. Come on. Don't waste my time or yours. Okay. This gets serious, and it gets serious real quick. This is where it starts, the rubber hits the road. Okay? This is when this class gets difficult. If you take good notes, you're going to do fine. If you're not participating and taking good notes, we're gonna struggle all year long. We need this. This is our base. Okay? All right. So, the Y-Intercept. We also need, okay, so we also need the Y-Intercept. Maximum and minimum values. Okay? And domain and range. This one, I'm not too worried about. We will be talking about it. It is tied to this. Think of it like this. Your equations are going to either look like this or this, right? So it's either frowning or smiling, right? So the first coefficient is either plus or minus. So it either opens up or it opens down, right? Okay. The vertex. It's either going to have a maximum or a minimum. Does that make sense? A maximum point or a minimum point. Okay? The vertex is that maximum. Okay? The vertex is that minimum. Okay? And lastly, it has, where's my green? Well, lastly, it has what's called the axis of symmetry. In other words, just like a face, well, not really just like a face, because if you look at your faces, right, they're asymmetrical. You know, students have pointed out that mine is very asymmetrical. Like, one ear is really higher than the other. One eye is very much higher than the other, right? So, right, the more symmetrical your face is, the prettier you are. Obviously, they're telling me I'm ugly. Okay? So, in a very nice way, though. I like that. At least they're very nice. They're nice about it. Okay? So, but the point here is that this axis of symmetry is where everything comes, it can be folded and it will come together. Okay? It's the same on one side as it is on the other. Okay? It's the mirror image. Okay? So, this is everything we'll be doing right here. Okay? Alright, so let's look at number 1. And number 1 says find the axis of symmetry. And it gives you this x minus 1 squared. Okay? And it's not number 1, it's actually number 13. Right? So this is going to be question questions 13 through, and I haven't decided yet. What is this? 2.2, right? The homework. 2.2. All right, and so we should be able to look at this. It's in the Vertex Formula, right? In essence, it's saying plus 0 out here, right? So remember, H is always the opposite. So it's going to be 1 and 0. So 1 and 0 is going to be your vertex. So what's your axis of sim? Your axis of sim is always H. Okay? So my axis is x equals 1. Okay? So when it's in the vertex formula, it's really easy. We'll have some problems in vertex form. Okay? But other problems, most other problems will not be in vertex form. Okay? So we're going to have to learn a method. And that method, I created a nice method that uses 4 steps. So I actually use this 5 steps, but I already have a 5-step method. So I made it use 4 steps. The 5th step is actually quadratic formula, which we are learning after the next quarter, at the beginning of the next quarter. You should know quadratic formula, or at least seen it. But right now we're just going to worry about 4 steps, right? And these 4 steps consist of finding the prime of f of x, setting it equals 0. This is going to give me the axis of sim. Okay? That's your first step. It's called finding the derivative. Okay? And I'll show you how to do that. F prime of x equal to 0. That gives you the axis of sim. Okay? Then, step 2 is you plug in the axis. And that will give you the vertex. Okay? So you will get a quadrant, a coordinate. Okay? So that will give you the vertex. Okay? That's step 2. Step 3 is the easiest part. It's finding the Y-intercept. Okay? So it's finding the value of 0. When x is 0, it will always equal c. That is your Y-intercept. Okay? Alright, and the last step is finding the symmetry point. The symmetrical point. Okay? The symmetrical point from this is always 2 times the axis. Okay? And that will also equal c. So this is what we do as our check method. Check if everything is going to be okay. Okay? We're checking to make sure everything's good. Okay? With this, we can graph the function. This will graph any quadratic. Okay? Any quadratic. So, let's look at 15. Problem 15. Okay? Problem 15 states f of x equals x squared plus x minus 2. Is that right? All right. There is another idea behind this. The other idea behind taking the derivative is 2ax plus b equals 0. Okay? that's based on the idea, okay, that ax squared plus bx plus c is a quadratic. Okay? Every quadratic can be written as ax squared plus bx plus c. Alright. So, we have the first step, finding the derivative. Okay? The derivative is really, really easy. It's the exponent times the first coefficient. Okay? So this is 1, right? So 2 times 1 is what? 2 times 1? 2. Okay, so f prime of x is equal to 2. And then I take 1 away from that 2. What's 1 away from 2? 1. 2x. And then there's a hidden 1 here, right? What's 1 times 1? 1. And then I take 1 away from that. Okay? Now here's the trick. Okay? Now when I was in calculus, they would just say, okay, now drop the number. And we go, why are we dropping just drop the number. Okay. Because you just got to keep moving. There's a reason why we drop the number. There's really an x to the 0 here, right? So what is, because that's 1. Remember, x to the 0 equals 1, right? So what is 0 times any number? 0. Okay? And that's why the number goes away. Okay? Now it would still be x to the negative 1, right? Because 0 minus 1 is negative 1. But what's 0 times x to the negative 1? Still 0, right? So we're adding nothing to it. So this goes away. And we set that equal to 0. Okay? That's it. So it's just 2 times this first coefficient plus this next coefficient. That's it. Every single time. 2 times the first coefficient plus the next coefficient. Okay? You can remember this formula. You can write down the formula, or you can remember how to do the derivative. It's up to you. Okay? But once I have this, now I solve. Minus 1, 2x equals negative 1. Right? Then what? What do we do? Come on. What do we do? Divide by what? 2. Yep. Okay? And we get x is equal to negative 1/2. Okay? And then you plug that in. So that's your axis of symmetry. Okay? That is your axis of symmetry. Huh? Yes, sir.
Where did the 1x go?
Huh?
The 1x. So I see how the x squared became 2x, but what happened to the other x?
We took 1 away from 1 and got none, right? So this became x to the 0 right here, which is 1, and 1 times 1 is 1. So that's what happened to the x.
Oh, okay.
Right? Good question. Alright, so now we got to that's our first thing. That's our axis of sim, right? Okay? Now we got to find the vertex. How do we find the vertex? Plug it in. Plug it in. Right? So, f of 1/2 negative, right, is equal to 1/2 negative squared plus negative 1/2 minus 2. You just plug it into the function. What is a half squared? 1/4, right? So we want to change this to 2/4, right? Minus 2. Now we could change this to just minus. Does that make sense? Because a plus minus is just a minus, right? So this is really just minus 2/4. Now this is how you know you're doing it right. Okay? Pay attention. You know you're right when the answer from these two is half of whatever they were. Right? So if it was 6, right, you should come up with 3. When you combine these two, it's always half of what it was. If it was 28, it should be 14. Okay? So one of these should be half of the other. Okay? In this case, this is half of this, right? When I subtract this, I get a negative 1/4. Okay? Minus 2. Now, f of 1/2 negative is equal to negative 2 1/4. That means that your vertex is negative 1/2 and negative 2 1/4. That is your vertex. Okay? That's your vertex. How do we find our Y-intercept? That's the fun part. That's the easy part. F of 0, right? If I plug in 0, I get 0 squared plus 0 minus 2. F of 0 equals negative 2. My point is 0 and negative 2. That was nice. That was easy. So the hard part to this is really plugging it in. Step 2. That's the hardest part. Once you get used to doing this step 1, K. Okay? Step 1's K. Plugging in, to the function, that's the hardest part. PEMDAS. Okay?
Does it say 0 squared?
Yes.
I can't see that.
0 squared plus 0 minus 2. Okay? That better? Worse? I'll have to put it in the back then, eventually. We'll rearrange these. Maybe these aren't the best desks then. Groups. How about if we move it over here? Does that hurt? Tony? Charlie? Can you see through it? It's like, I like your enthusiasm. Charlie, thank you. Alright. So, we have our, what's it called? Y-intercept. Good. So we have our Y-intercept. Okay? And so we need our symmetrical point, right? We need 3 points. We need 3 points. Right? Alright. What's the last one? Red? Alright. So the last one is we're taking the function of 2 times the axis. Now what's the axis? How much is the axis, the sim? Negative 1.5, right? Or 1/2, sorry. Okay, so what's negative 1/2 of 2? Or in other words, what's half of 2? It's 1, and a negative times a positive is a negative, right? So we're trying to find the function with respect to negative 1. So that means negative 1 squared plus negative 1 minus 2. What is negative 1 squared? Isn't that 1? What is negative or plus and minus? That's just minus 1. So 1 minus 1 is 0, right? And so what we are left with is f of negative 1 is equal to negative 2. And this is our point of symmetry. Negative 1 and negative 2. Right? And so we can graph this. Let's take a look right here. Do we know which way it opens up? Which way does this open up? Is it smiling or frowning? Smiling, right? Because it is positive, correct? Smiling because it's positive. Okay? Alright, so does that mean it has a maximum or a minimum value? Minimum. Good. So we're talking about this guy right here. Okay? When we graph this, the vertex is at 1, 2, 3. 1, 2, 3. Okay? So we're talking about negative half, right? We'll talk about negative half, negative 1/2, right? And then we're talking about negative 2 1/4. So at negative 1/2, we have this axis of sim. At negative 2 1/4 on the axis of sim, we have our point. Okay? If we look at this, we cut this in halves, right? So 2 1/4 would be here. Negative 2 1/4. Sorry. Right? So that's right here. That would be what we call the minimum value. Okay? Your minimum. Where is your Y-intercept? Is that 0, negative 2? And where is your axis or your point of symmetry? It would be at negative 2 and negative 1. And this would be your graph. Okay? So it's asking for a few things. The vertex, the axis of symmetry, the Y-intercept, and graph the function. Did we do all of that? Yes, 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 and yes. Ta-da. Okay.